Hey guys, welcome to this video. Let's discuss an interesting concept in this video, which is called the arrow of time. So what is the arrow of time? Of course, time moves only in one direction, from the past to the future. Time points from the past to the future and not the other way around. It's like an arrow, and you cannot change the direction of the arrow. And this might sound obvious, like why would you expect time to point from the future to the past? But uh, as a physicist, this is puzzling to physicists because the fundamental laws of physics, for instance, in quantum mechanics, we have something called unitarity, which in technical terms it means that the time evolution of a quantum operator of a quantum system it is unitary. That means it can be represented by a unitary matrix, unitary operator. Operators in quantum mechanics they're represented by some Hermitian matrices, right? Those are all technical terms, but basically this means in quantum mechanics, I mean at the quantum level, at the microscopic level, the probability of an event A to B is the same as the inverse probability B to A, which means if some event occurs A to B, then no information is lost about the event. You can in principle it's possible to retrieve all the information, and that means and technically you can move from past to future or future to past, in theory, in quantum mechanics. And yeah, there has been recent studies and all which proves that in open quantum systems that interact with its surroundings, there are two arrows of time. Both arrows of time, both directions are possible. But in the physical world, in the macroscopic world, we observe only one arrow of time, that's from past to the future. And of course, we observe a cup can fall from a table and break itself, but not the reverse. A broken cup cannot repair itself, right? You can see. And but now why there is an arrow of time. It's a very deep question. Some people say that it's because of entropy, the second law of thermodynamics. Some people say otherwise, but that's a topic for another video maybe. But yeah, in this video, what I want to argue, what I want to not argue, what I want to discuss is that I want to discuss the three arrows of time. So there are basically three arrows of time, and they are the cosmological arrow of time, the psychological arrow of time, and the thermodynamic arrow of time. And the main thing I'd like to address in this video is why the three arrows of time point in the same direction in our universe. First of all, what do I mean by these three arrows of time? Okay, so the cosmological arrow of time is related to the expansion of the universe. We know the universe is expanding as time moves from the past to the future. So this is how we define the cosmological arrow of time, because we know that the universe is expanding. Based on our observations, we know that it is not contracting. So the universe can only expand in one direction, in one way. It's a unidirectional phenomena. The universe can only expand, it cannot contract. So this is how we define the cosmological arrow of time. It points in the direction of the expansion of the universe. That means in principle, if we say the universe suddenly starts contracting, then the cosmological arrow of time would reverse its direction. Thermodynamic arrow of time is based on entropy. Entropy can only increase for a closed system. It cannot decrease. It can only increase, or if the system is not in equilibrium, it has to increase. Otherwise, it can remain constant, but it cannot decrease. The entropy of a closed system cannot decrease. And you can treat the universe as a closed, isolated system, though there are many arguments here, because when you're talking about something like the universe, you have nothing beyond. It's very difficult to define this stuff for the universe. But yeah, basically, we often treat the universe in such a way. And the thermodynamic arrow of time actually is the arrow of time which arises out of entropy. That's how it's thought. Like entropy can only increase, and due to the increase in entropy, since entropy can only increase like from the past to the future, that is how we define the thermodynamic arrow of time. It's the direction of the increase of entropy, because entropy cannot decrease. Now there is a third arrow of time which is very much related to the thermodynamic arrow of time. It's called the psychological arrow of time. It's our subjective perception of time, and this is aligned with the thermodynamic arrow, because for instance, we only perceive things to get more disordered over time, and you can think of it more technically like this, more appropriately, more precisely like this, and that's that. Okay, let's think of it like this. As you form a memory, the local entropy in your brain decreases. Yes, because before the memory is formed, all the neurons are firing randomly. The degree of disorder or randomness in your brain is pretty high. The number of possible configurations, pathways is high. But once you form a particular memory, that means neurons are firing across a particular pathway in your brain, and that means the locally in your brain the entropy decrease, the disorder decrease. But that doesn't mean it's violating the second law of thermodynamics, because to form a memory you have to do a lot of effort, and that means maybe the temperature around your brain increases and a lot of other things can happen. So, but yeah, basically the thermodynamic and the psychological arrows of time are always point in the same direction, that we know. Cosmological arrow of time, it's not necessary that they point in the same direction, but they, yeah. So basically, when we talk about the cosmological arrow of time, so we don't exactly know. There are hypotheses, there are theories, but we don't exactly know why the cosmological arrow of time points in the direction of the expanding universe. And as the universe is expanding, entropy is increasing, more volume is available to the particles in the universe, of course. So we know for sure that the psychological and the thermodynamic arrows of time point in the same direction, and in our universe, at least in an expanding universe, the cosmological arrow of time point in the same direction as well. But it was, at least in theory, it was perfectly possible that the cosmological arrow of time points in the opposite direction. Say the entropy is, because even in the, if, even if the universe were contracting, entropy could still have increased, because if the universe is contracting, maybe the volume available to the particles, number of spatial configurations is decreasing. But if the particles are like, suppose something like photons, they're radiating, if the particles radiate energy, then the number of energy configurations, velocity configurations might increase. I mean, it's not like if you contract a system, the entropy will always decrease depending on the on the behavior of the particles, the total number of I mean, when you define entropy, it depends on the number of microstates. That's not just the velocity, that is not just the number of position configuration or spatial configuration, that also depends on the number of energy configurations, the number of velocity configurations of the particles, the microstate, the entire microstate of the statistical system. That's a technical term, but yeah. So we don't exactly know why all the three arrows of time point in the same direction, at least in our universe. But here is an argument which does not answer the question, but at least gives us some insight about the problem. It's that for intelligent life to emerge and evolve in a universe, the three arrows of time must point in the same direction. Because, for instance, to stay alive, we take food, which is a kind of food, and this kind of nutrients and all, they are ordered chemical compounds, and we break them down. Our body breaks them down into more disordered pieces, and we use that to stay alive. I mean, many more things. I mean, we actually, if the second law of thermodynamics was not true, then we would not be alive. It's often said that life is a disequilibrium, and life, yeah, of course, locally, I mean, for as long as we're alive, for 80 years, 70 years, whatever, our brain decreases the entropy of itself locally. But the overall entropy of the universe, the system plus surroundings, it still increases. The second law of thermodynamics is not violated. On the contrary, it is necessary for life forms to exist and evolve. Because the brain and our bodies in general, they're open systems. We exchange information with the surroundings, we exchange energy with the surroundings, so on and so forth. Now that is the point. See, the thermodynamic arrow of time, and as a result the psychological arrow of time, they have to point in the direction that they do for life to emerge and be able to sustain itself in this universe. And the cosmological arrow of time has also must point in the same direction as these two. I mean, all the three arrows of time must be aligned for in a universe where there can be intelligent life form. And it's not just it's not just enough to say that life can emerge. The conditions should also be conducive to the evolution and sustain. I mean, the life should also be able to evolve and process information. It's if I'm conscious but I cannot process information, I cannot perceive the flow of time, then it's almost like I am not conscious technically. And now if the universe would have contracted, then the contraction would have exponentially, I mean, the contraction would have become faster and faster, because as the average distance between the particles in the universe, galaxies, stars, whatever, would decrease, the gravitational pull between them would increase very much, because it's inversely proportional to 1 over r square, and r is the gravitational pull. R is the average distance between the particles, right? You can think of it like that. So it's inversely proportional to 1 over r square. As r decreases, the gravitational pull increases, and the universe would suddenly collapse. And then as the universe is collapsing, the temperature is increasing, the energy is increasing. As the universe is expanding, it's cooling down. If it contracts, it would heat up. So of course these conditions are not really very much favorable for life forms, for intelligent life. So this is called the weak atrophic argument or anthropic principle. This is very well discussed in Stephen Hawking's famous book, A Brief History of Time. And this gives us an insight about as to why the three arrows of time point in the same direction in our universe, because otherwise we would not be here asking this question. But it still does not satisfactorily answer the question, like I mean, whether such a universe is possible where the three arrows of time are not aligned. What would it look like? And I mean, of course, the arrow of time and entropy, these are all very fundamental concepts in physics. Lot of arguments, lot of debates, and there are still like no consensus, because yeah, I'll make some more videos on these topics in the coming days. Recently I was actually doing a bit of study on these topics, and yeah, so anyway, I hope you enjoy the video. Thank you very much.